So we're going to go ahead now and look at 2.1, and we're going to look here at question 15. Okay, now, what are we doing on 2.1 question 15? Well, we are solving, right? Equals minus 8m minus 15. Okay, so when we solve, what do? Let's review how we solve. What do we want to do? We want to get all the variables on the left, correct? We want all the numbers on the right. Before we do that, though, we look and we make sure, are there any parentheses to work with first? No. If there were, we would work with those. Is there anything that we can combine together on the left-hand side? No, those are unlike terms. Right-hand side is the same way. So now, our goal is to get the m's, or the variable, in this case it's an m. We want to get that variable by itself on the left-hand side. We work with opposites, so a minus 8m. What's the opposite of a minus 8m? A plus 8m. Okay, so those can go away. And what does that leave you with? 1m, or just an m, minus 26 equals now a minus 15. What's my next step? Okay, well, what would I do next? We're going to do what? Yep, get the numbers on the right. So that 26 is negative. So how do I get rid of it? Add it. And what does that give you? Well, we've got 26, right, minus 15. 26 is the larger number. That's a positive. So my answer then would be m equals 11.
Okay, on that, it doesn't matter which side the numbers on, but whichever the larger number is. Yeah, I was confused.
Okay, you want the variable, the m, by itself on the left.
I understood.
Yep, and numbers on the right. But,
See, you took the 26 off the left side.
right, because it needs to go to the right side. Because I want to get this m by itself. And so I work in terms of opposites. Okay, let's look at 19. But yeah, what you want to do is you want to make sure that the numbers go to the right. Variables stay on the left. So let's look at 19. 0.200x. And we've got a minus 3. And that's going to equal 1.200x. Now, different ways of working this out. I like to always do it the same exact way, even though it may add on a step. So we want to get now the x by itself on the left. So what do I need to do with the 1.2? Subtract it off. Okay, and what does that leave you with now? When we do that, these go away, right? And that leaves you with a negative x, or minus 1.00x, the same thing, minus x there. And then we've got a minus 3. Now, what happened on the right-hand side? Those went away and left you with what? 0. Okay, what are we going to do next? We need to get the 3 to the right-hand side. How do we get rid of it? Move it over with addition. And that leaves you now with minus x equals positive 3. Is that our final answer? No, why not? Can't have a negative x, so we divide by 1 everywhere. And that now leaves you with x equaling negative 3. Okay. 2, 3, and 4. Yep, no problem. Does that make more sense now? What you want to do is you want to get all the variables on the left, for the variable on the left, numbers on the right. Now on 2, 3, and 4, let's look at question 9. Now these, some of them may have fractions. Some of them are going to be just working with the parentheses. These are a little bit different. Okay, so question number 9. What we have on question number 9 is we've got decimals. And we have parentheses. Now, when we talk about order of operations, what do we do first? Okay, before we do anything else, the parentheses have to be dealt with, right? So the very first thing that I would do is I would go ahead and distribute that 0.39 through. Where do I stop? At the parentheses. And then I would distribute the 0.38 through. Where do I stop? Parentheses there. Remember, the parentheses tell you where to begin and where to end. Now we just use our calculator. So let's go ahead and work with this one. When we distribute through, put it over here so we can kind of see it. When we distribute through, what do we have? We have 0.39x, because that just goes through. And then what do we have next? Next we've got 60 times that 0.39. And that gives you 23.4. Now we stop. Why do we stop? Parentheses. A lot of times students make mistakes when they're just learning and they try to push that through everything. No, we stop at the parentheses. Parentheses tell us where to stop. Then we distribute through and we get a 0.38x. And then what do we have here? Okay, here we have 0.38 times 50. And that gives you now 19. Before we start moving things around, we have to look on the left and the right and make sure we can't combine like terms. When we look on the left, can I put some terms together? Yes, those can go together. So the x's can go together. They're on the same side. They combine. So 0.39 plus 0.38, that gives you 0.77x. Okay, and then what do we do with the numbers? Numbers can go together as well, can't they? So 23.4 plus that 19, that gives you 42.4. And that equals a minus 42.3. Is everyone okay with that so far? Now, we just did one of these in 2.1. What do we now need to do? We now need to move that 42.4 over. It's addition, so the opposite of that addition is going to be subtraction. Now we have 0.77x. These have the same sign, right? So they go together. Just add them together. And we've got 42.3 plus 42.4. That gives you 84.7. And how do we finish it? Divide by that minus 0.77. That's always, bless you, it's always the last thing that you do. Divide that by 0.77. And that gives you then 110 for your final answer there.
For answers, you just want us to give them as whole numbers and not follow decimals?
Yeah, I mean, this one's a whole number, right? If it was a decimal, you could keep it as a decimal, but it should have been a whole number. But if it's decimal, you can keep the decimals. If it's a fraction, you keep the fractions. But yeah, this one should have came out to be 110, which that should have been a whole number, right? So we distributed through the parentheses first. We were very careful. Use a calculator. If you're not good at mental math or doubt yourself, use a calculator. That way you don't make a mistake. Because the worst thing that you want to do is to work through questions and miss them just because you added wrong. So always, always use a calculator. I use it all the time, even though I'm good at mental math. I just do that so I don't make a mistake on accident. So question 12. Question 12 has the fractions. And we have parentheses. Okay, so let's go through our steps. The very first thing that we always do is parentheses. Those go first. So we're going to distribute through. And what does that give you now? Okay, if you struggle with fractions, you can work them over to the side. We've got 1/4 x. It just goes through. And then we've got 1/4. And what are we going to have to multiply it by? Over 1. Okay, and you can cross cancel. 8 and the 4's cancel, and that leaves you with the 2. So that's going to come out to be a +2. Then we've got 1/2 x, right? And then what's 1/2 times 2 over 1? Let's cancel again, and that leaves you then with a what? +1. Okay, so everyone all right with that so far? Now, what do we need to do? Go ahead and clear out the fractions. What do we have for our denominators? It's very easy on this one. Our denominators are a 4 and a 2. Well, 4 goes into 2 and itself, so I'm just going to go ahead and multiply everything by a 4. Now, you could have cleaned this up first. You could have combined the 2 and the 1 here together first. That would have been all right as well. A lot of times, though, I just have you get rid of the fractions at the beginning. The quicker we can get rid of fractions, the easier it is, I think, for students to not get intimidated by them. So I always try to get rid of them as soon as possible. Now we're going to distribute through. 4 and 4's cancel, so that leaves you with an x. 4 times 2 is an 8. 4 divided by 2 is a 2. Times 1, that makes it a 2x. 4 times 1 is a 4. And that equals x minus, sorry, not x minus 9, it's what? Make sure you distribute through. 4x minus what? 36. Yep, make sure you don't make a mistake there. Okay, that's 4x there. Because it has to go through each and every piece. Now, what are we going to do? Well, we're going to combine. So let's work on the left. The x's can go together. So an x and 2x makes it 3x. 8 and 4 makes it a 12, and that equals 4x minus 36. Now we've got something we can deal with, right? All the hard part is done. Now we just simply move it around and solve. So what's next? Move that 4x over. And 3 minus 4, that leaves you with a minus 1. So we don't need to write it, we just write a minus x. Yep. Can you please turn that off so it doesn't make noise anymore? Plus 12, and that equals now a minus 36. What do we need to now do? We need to move that 12 over. And now we've got a minus x equals a minus 48. We'll divide by our negative 1. And negative makes that positive. Negative and negative here also makes that a positive now 48. Okay, so is everyone okay with what we did? Does that make sense? So I got a 48. Hopefully everyone else did too. Make sure I added things correctly. Watch your signs. Where do students make a mistake? A lot of times it's in the signs, especially like with this 12. Okay, move that 4 over, right? That gave me a negative x there. Now that 12, a lot of times I see students get in a hurry and accidentally add 12 to both sides. We don't add 12. Why not? Because it's a positive 12, so to get rid of it, we do what? Subtract that 12. Those go together. They're the same sign, so we add them together. And that gives us our minus 48, right? Then we divide by negative 1. Why do we do that? Because we need to get the x by itself as a positive x. And that gives us then our 48. Is that making more sense now? And watch out for the simple mistakes. Where students a lot of times get into trouble is with the simple mistakes. Things like adding when you should be subtracting. That's the most common one. So always take your time and try to be organized with these. If you have work all over the paper, that's where you struggle at. So like on this one, you see what I did. When I had to do work, what did I do? I did this over here. Okay? Everything on the left is pretty well organized. Everything on the right, that can be whatever it needs to be. That's my work. I separate it out. That way, I don't get confused as to what I'm doing. A lot of the frustration comes from losing track of where you're at. I'm not remembering, okay, what did I just do? So that's the easiest way is divide that paper and work it out that way. Okay, question 20. We've got 6m minus 8 equals 8 plus 3m minus 7m. Okay, so what's the first thing that I should try and do here? Before we move things around, I need to look. These cannot go together on the left, but on the right, those can go together, can't they? So the very first thing I do is I see that those can go together. When I write them, I usually write the variable first. So we've got 6m minus 8 on the left. That stays untouched. What about the right? 3m minus 7m. Is that a positive or a negative 4m? Negative. Okay, be very careful with the signs there. So it's a minus 4m. And then we've got a plus 8. Okay, what's next? I like to move the variables. So what should I do next? Okay, add that 4m, right? Okay, that's going to take care of that. Adding those together, that gives you 10m. And then we still have the minus 8, and that equals a positive 8. Here's where students make a mistake. Those 8s are not going to cancel out. I've got to move that negative 8 over. When I move that negative 8 over, it becomes addition. But a lot of times I see students, they say, oh, look, the 8s are here, they're going to cancel out, make 0. We need to make sure we're careful. We move it over with addition. So they don't cancel out now, they add together, and 8 and 8 makes it 16. Now we've got 10m equals 16, right? We can now divide by our 10, and we always need to make sure that we can't reduce. This is going to reduce, and how do I know this is going to reduce down? These are both even numbers, okay? If they're both even numbers, then they at least have a 2 in common. And so 16 divided by 2 is an 8, and 10 divided by 2 is a 5. So that would come out to be 8/5. I can't go any further because 8 and 5, they have nothing in common. But a lot of times, what are students going to try to tell me the answer is? 0, because they try to move things around incorrectly. Watch your signs. Take your time. Okay. Now we're going to look at these applications. And we're going to look at question 3. Let's review a bit of the terminology. We looked at angles. Okay, when we talked about angles last class period, we talked about the complement. And the complement was 90 minus x, right? Remember that because we'll need these definitions. And we also needed the supplement. And what was the supplement? 180 minus x. So make sure you have those because we're going to need them here in a moment. So those are things we're going to have to remember. Now, question number 3 is where we're going to begin. And this is a angle question. So let's read it. We'll talk about it. Okay? And then we'll try to set up our equation, solve it, and get our answer. So find the measure of an angle such that the difference between the supplement and 3 times its complement is 50 degrees. Now let's think about this in terms of each part. Find the measure of an angle. Okay, that tells me that I'm solving it for x. That's what that means in words. When it says find the measure of an angle, that means find x. And we want to find x, and what's our equation going to look like? We want the difference between, so that means subtract, the supplement and 3 times its complement is 50 degrees. Okay, that is means equals. So let's see what we've got. Difference between the supplement and 3 times its complement. So that means our supplement minus 3 times the complement means equals. And what does it equal now? 50 degrees. So there's our equation, right? Is everyone okay with that? Fill it in and see what we've got. The supplement, that's 180 minus x. And we've got a minus 3. Now the complement, we're going to put parentheses around it because it's getting filled in. Whenever we fill in something, we use parentheses. So that's a 90 minus x there. So it came down for our complement. Okay. How would we finish this? Well, I would begin by distributing, and here's where students make a mistake again, that negative in front. It's a minus 3. So whenever we have a negative like that, I like to circle it. So I remember it's not just 3, it's a negative 3 that pushes through. So now we have 180 minus x. 3 times 90. Yep, and it's a negative, so that's a minus 270. Negative and negative here, that makes it a positive. 3 times x, that's a 3x. Okay. Now we can combine like terms together. I like to write the variables first, so let's deal with those. We have a negative x and a positive 3x. So 3 minus 1 is a 2, right? So that's a 2x there. And then we've got 180 and a minus 270. And 180 minus 270, well, that should give us a minus 90, doesn't it? 180 minus 270, always double check things. And it's going to give you that minus 90. I always double check just to make sure I don't make a mistake when I work these out mentally. And what's my next step going to be? Add the 90. Right? Okay, so that takes care of that. And now we've got 2x equals, adding those together, 140. Divide by our 2. And now we have our answer, which is 70. And that's going to be 70 degrees there. So that takes care of question number 3. We've got several others to look at. Let's talk about question 8 next. And if you got more, we can add them to the list as well. Okay, now, question 8 is a triangle. And we talked a little bit about triangles last class period. And what do we know about the angles in a triangle? They're going to add up to be 180. Right? So that's very important that we remember. And it even says here, they add up to be 180. So the sum of the measures of the angles of any triangle is 180 degrees. In triangle ABC, angles A and B have the same measure, while angle C is 30 degrees larger than each of A and B. What are the measures of the three angles? Well, first off, we know we have the three angles, and that's A, B, and C, and they're going to add together to give us 180. Is everyone okay with that? Right? We know they have to go together to give us that 180. Now, what do we know about A and B? They're the same, aren't they? Right? So A equals B and B equals A. They are the same. The one that we need to make sure we understand how it relates to these is angle C. And what does it say about angle C here? It says the measure of angle C is 30 degrees larger than each of A and B. And why does it say for each of A and B? Because A and B are the same. So what is this basically saying? This is basically saying that C is going to be 30 degrees larger than A or B. So that's 30, and we'll just use plus A. You could use plus B, it doesn't matter, as long as we've got the variables defined. Now, we know A and B are the same, so let's call A x. If I call A the variable x, then that means B is also what? The variable x, and that means C is now going to be 30 plus what? X. And there is our equation. So we can now fill it in, and that equals your 180. Combine your x's together, and that's 3x plus 30 equals 180. So this can go together. My next step would be subtract our 30 from each side. And if I do that, then I have 3x equals now 150. Okay. And what do we do for our last and final step here? Yeah, we're going to divide by our 3. And that leaves me then with x equaling 50. But that is not our complete and finished answer, because it wants you to find all three angles. So now we plug them back in. So we know our x is 50, so that means A is 50 degrees, B is 50 degrees, and what about C? Yep, that's going to be 30 plus 50, which is then 80 degrees. Now we know that we did it correctly because these should add up to give you what now? 180, and do they add up to give you 180? Yes, so we know we did it correctly. But you see how I set that up. Now, where do students usually struggle at? In the wording. And where is it the trouble with the wording? Right here. While the measure of angle C is 30 degrees larger than each of A and B. Now, why does it say for each of A and B? Because they're the same, right? So all that's saying is that's just either plus A or B. And so whichever one is x, it's just going to be a plus x there. But I wish they wouldn't have even done that. I wish they would have just said, while the measure of angle C is 30 degrees larger than A. That would have made it less confusing for students. But sometimes they're written that way. And so that's a lot of times where the mistake on that particular problem lies. It's just in the wording. Okay, let's look at 10 next. I'm not going to completely work out 10, but I'm going to set up the equation, and then I'm going to leave it for you to solve. Now, this one again is a supplement and a complement problem. Question 10. Find the measure of an angle if its supplement measures 50 degrees more than twice its complement. So find the measure of an angle. That just tells me that I am solving for x. That's what it means in English here, is we're just solving for x. Supplement measures. Now in this case, measures, in this particular problem, this measures, that means equals. So the supplement measures or equals 58 more than twice its complement. So what would that look like? When I write it down, we've got our supplement. The measures means equals again, right? Okay, so we got to make sure we understand that. So supplement, measures is equals. And what does it equal? 58 more than twice its complement. So that's 58 plus 2 times the complement. Now we can get the equation. Okay, the supplement, remember we talked about this before. The supplement is 180 minus x. Then we've got 58 plus 2, and the complement, well, what's our complement? Okay, 90 minus x, wasn't it? Remember that? We had that defined out. So that goes there. And now you can finish it from here. I know we struggle more with the setup than actually solving it, but do we see how I set it up now? I like to write it in words and then replace those words with what they are. And key things like measures, okay, sometimes measures can mean equal. You just have to be very careful with the wording, and sometimes you may want to read these 2 or 3 times just to let it kind of soak in, so you understand what it's wanting you to do. Okay, question 11. There's no really way to set up and write an equation for question 11. This is just a question that you can just think about and work through. Not everything requires an equation. So pennies are packaged 50 in a roll. A mother gave her son 95 pennies for his bank, and she had 5 pennies left over. How many rolls of pennies did she use? Well, what do we have? How many total pennies do we have? Let's talk about that. The total pennies. We gave our son 95 pennies, right? And then he had 5 pennies left after we did that. Sorry, after we gave him the 100. So we gave him the 100 pennies, or 95 pennies. She gave him the 95. He had 5 left over. So that means we have 100 pennies total, right? Okay. Now, how many pennies are in a roll? Yep. 1 roll is 50. And so that means if we have 50 per roll, we have 100 total. That means we have 2 rolls of pennies. And you can write an equation for this and you could solve it, but sometimes you don't need to. And does that make sense? Yes. Why? Because if I've got 2 rolls of pennies, how many total pennies did I have? 50. Or 50 apiece, so that's 100. Okay, I gave 95 to my son, 5 left over, that makes 100. So not everything requires an equation. You could write one up, but you really don't need to. Because if you wrote it up, I think it would be more confusing. And sometimes, just think about things in a real-life application. And don't try to overcomplicate things. Because if I ask you this question in a non-math course, you'd be able to answer it. But sometimes students, when they get in a math class, just focus so much on things that they forget the simpler things. So that was question 11. Okay, question 12. Question 12, again, is a triangle. So the sum of the measures in any triangle is 180 degrees. In the triangle ABC, A and B again have the same measure, while angle C is 12 degrees larger than each of the other 2 angles. A little bit different wording. That's why I picked it. It's very similar to the one we did. A little bit different wording, but it's set up the same way. We want to find the measure of angle C. So what do we know first off? We have a triangle. Okay. And we know this triangle has the three angles, A, B, and C. And those add up to give you 180. Now we need to see how they relate. So let's see what we've got. A and B have the same measure. So A equals B, B equals A. Okay, so we know that. And what else do we know? Angle C is 12 degrees larger than the other two angles. Okay, when it says other two angles, that means that, we know they're the same. So when I wrote this up, you could just write it as 12 degrees larger than the other two, than each of the other two. So that would be 12 plus A. Okay, you can use a 12 plus B. They're the same thing. We're not adding them both on there. We're just adding the one. And now we rewrite with our variable x. We're going to let A equals x. Then B also equals x, right, because they're the same. And C is going to be 12 plus what? X. Okay. What does our equation now look like? Replacing, there's A, there's B, and there's C. And I think you can finish it from there. You'll be able to add those together, move the 12 over and divide. What I usually do on this one is I would go ahead and get all three angles. And it only wants angle C, but I would get them all, and then I would just put a box around the one that you need. In this case, you just want angle C. Okay, so that takes care now of question 12. Question 13. This is another one that has a total. And let's look at this one. And this is a ratio type of question. So a paint mixture contains 39 gallons of base for every 1 gallon of color. In a total of 600 gallons of paint, how many gallons of color are there? So if we go to the paint store and we buy paint, okay, if we go to the paint store, we buy paint, on the shelf they're all white. What do? We take it over to the machine, right, and the employee puts the color in there. Not very much at all. So very little color. All those paints are white, but a little bit of color changes the entire paint. So there's going to be a lot more of the white base than there is the color. Now there's a ratio that they use. So let's see what we've got when we read this. A paint mixture contains 39 gallons of base for every 1 gallon of color. So it's going to be a 39-to-1 ratio. And what does that mean? Okay, well, that means that the base we don't know, but the color, the color we don't know, but the base is going to be 39 times as much. Right? Okay, because we know if we have the base and we have the color, we don't know how much color we have, so we're going to replace that with an X. But how does the base relate to the color? There is a lot more of the base, right? It's 39 times more base than the color. So that's why it's going to be a 39-to-1 ratio. So 1X and the 39 color here. Now, when I rewrite that, your base is now going to be what? 39X. Your color is X. So there's that. That's all taken care of. Now, what does my equation look like here? My total is how much? How many total gallons of paint do I have? 600. So my total is going to be that 600. Now, what does that total paint contain? That contains, when I talk about the total, that contains the white base plus the colorant. And that is going to equal now the 600. Okay? And now we know what the base is and what the colorant is. So the base is going to be 39x. The color is unknown. That's x. And that equals now 600. And I think you can finish it from there. It's going to come out to be a whole number. That's going to be the color. Multiply it by 39 to get the base. And they should add together at the end to give you the 600. But you see how I set up the ratio here? Because it was a 39-to-1 ratio. We know that there's a lot less color than there is the base. Common sense tells us if we go to the paint store, we don't buy a gallon of just pure color. It's that white base, right? I take it up and I tell them I need this green. They put the colorant in to make it work, just a little bit of colorant. So that's a 39-to-1 ratio. So that means there's a lot more of the base, 39 times as much of the base as there is the colorant. Okay, so that's now question 13. See, that was 14, wasn't it? Or was that 13? Let me look. Yep, that was 13. Okay. Now we're going to be ready for 14, and then we'll take a break after we work through 14. So let's think about 14. The difference between two positive integers, so they've got to be positive here, is 44. One integer is 3 times as great as the other. So this is kind of similar to what we just did a moment ago. What are we looking at here? We're not looking at color and base. We're looking at two numbers. So we have a small number and we have a large number. And how do they relate to each other? Well, it says the difference between two positive integers is 44. We're going to come back to that in a moment. But first, let's try to figure these out with words. One integer is 3 times as great as the other. So that means the larger integer is 3 times the smaller integer, right? And we don't know the smaller integer, so I'm going to use an x for that. So that tells me then that the small is going to be x, and the large integer is going to be 3x. Is everyone okay with how I set that up? Right? Now, once we have determined what we're working with, now we can think about the equation. The difference between two positive integers is 44. We have to make sure that we put them in the correct order. Now, we know these are positive numbers, right? If I take the larger number minus the smaller number, that's going to give you that 44. Why would it not work if I did this? Why would it not work if I wrote it with the small number first? Because it would make it negative, right? If I did this, this would be a negative 44. Well, I don't want a negative 44, right? We want it to be a positive 44. So you have to make sure that the larger number is first. Subtract off the smaller number. That way it stays positive. Otherwise, you'll end up with negative answers. And what about the large number? Okay, that's going to be 3x. What about the small number? X. And what does that equal? 44. And I think that you can finish it from there, right? You've got your equation. Should be very, very easy to set up and solve. Just basically put them together and divide by 2. So is that starting to make a little bit more sense on these? Do we kind of see how they're set up? What's the key takeaway? Well, when I work with these applications, the key takeaway is I always read it first. I take my time. Now, if you think you need to read it again, read it again. Read it again until you really understand what's happening. And sometimes I like to think about it, okay, what is this really meaning? Like the paint, okay? I know how paint works. When we did question 13, I bought paint before. Everybody in this room has bought paint at the paint store before, right? We all know we go to the paint store and those paints are not colored. What do? You pick up that big gallon of paint. Okay, it's pure white. You go up to the counter and you say, I want this green or this blue. What do? They add just a little bit of color. So I know there should be a whole lot more base than there is color. Common sense tells me that. So when we read through these, we have to think, how does this relate to what I'm really looking at and what I've done in the past? And if you do that, it makes it a lot more relatable and it makes more sense. So we're going to work with some more of these, but let's go ahead and take a short break.